Hello once again, everybody. It's time now to look at bivariate data. Now, assume you've had a look at univariate data. That's things like favorite color, favorite car, height, things like that. One variable we're just checking on. Bivariate means where we're looking at two variables, bi for two. So this is a quick introductory video where we're going to look at what bivariate data is and how we can talk about it. So here's just a quick list of what we're going to go through. First up, we're going to look at what is bivariate data. Pretty straightforward. We'll figure that one out. Second thing, we're going to look at how we display bivariate data. And here's a display of it with the scatterplot. That's the most common one. We have one variable down here and the other variable up the side. Now, we've all drawn scatterplots. Fun, aren't they? Lots of dots to put in. This one was 50, 60 dots there. That's going to take a while. So what we're also going to look at is how to do scatterplots on the CAS calculator. Much, much quicker. We are also going to look at how we describe what we see, the relationship between the two variables. And more specifically for year 11 and year 12, we are going to talk about Pearsons correlation coefficient, where we actually quantify what's going on. Ready to go? All right, let's have a look at what bivariate data is. Well, basically, it's where we have two variables and we want to check if there is a relationship between the two variables. Whereas univariate, you might have two variables, boys against girls, for example. There's a pretty typical, who gets the higher test scores? Well, we all know girls generally get the higher test scores, sorry guys. But that's two sets of univariate. We're comparing the individual results. Bivariate is where we want to see if one affects the other. If boys get higher scores, does that mean the girls' scores go up? That's what we want to look at. Let's have a look at a couple other examples of possibly bivariate data. The amount of cloud in the sky and the amount of rain you'd expect. Well, that makes sense. If you got no cloud, you wouldn't expect any rain, would you? So one depends on the other. The number of children in a family and the weekly food bill. More kids equals more food. Straightforward. The heights of boys in a class and the heights of girls. Does that mean if you've got tall boys in the class, you're going to have tall girls in the class as well? Well, no, that's what I was talking about before. This is comparing two sets of univariate data. There's no relationship between the two. So how do we choose? How do we check, that a data is bivariate? Well, essentially, all we need to do is put the variables in a sentence and using the words respond to. Sometimes we could say is explained by, but I prefer to use the words responds to. It just makes the sentence neater and makes it easy to find one of the variables in particular, which I'll talk about in a second. So anyway, let's have a look at this first one. We'll put this in a sentence. The amount of rain responds to the amount of cloud in the sky. That makes sense, doesn't it? Or you would expect the amount of rain to respond to the amount of cloud in the sky. This one, you would expect the weekly food bill to respond to the number of children in the family. Makes sense too, doesn't it? What about this third one? Just checking. We've already decided that it's two sets of univariate. The heights of girls in the class responds to the heights of the boys. It doesn't really make sense, does it? Nothing to do with each other. It's more to do with your parents outside. Okay, no good. All right. Now that's led me to talking about the two types of variables. They are called the explanatory and, you guessed it, the response variable. So we need to pick the two. In science, we don't use the words explanatory response. We use independent and dependent. You've probably been doing that in all your pracs since about year 7. So you put the independent variable and you're checking what happens to the dependent variable. But in stats, we use the words explanatory and response variables. So the explanatory variable is the independent variable and the response variable is the dependent variable. How do we check which is which? Well, believe it or not, seen this before. Put the variables in a sentence and use the words respond to. That's the way I do it. So what are we doing here? Sorry. One bit I forgot to mention, only one of the ways will make sense. So let's have a look at this one here. The weekly food bill responds to the number of children. So that's one of the variables, the weekly food bill, and the other one is the number of children. If we swap those two variables around, the number of children in the family responds to the weekly food bill. Does that mean if you buy more food, you're going to have more kids? Unfortunately, that doesn't work at all, does it? Nope. It's the food bill responds to the number of children. You have the children before you feed them. So what that gives us is, let's have a look. This variable here, the weekly food bill, responds to, that's giving the hint. The weekly food bill responds, so that is our response variable. Okay, it's one of the trickiest things to do. Put it in a sentence to decide which variable is which. Possibly the easiest way to explain it is by having a look at an example. All right, and to do that, we talked about scatterplots, representing bivariate data on a graph. Well, we're going to draw a scatterplot here. Now this table here, there's lots of numbers here. There's two variables, there's age and price. And it's about the price of used motorbikes, comparing it with the age of the bike. So first thing we need to do is, well, we're going to draw it on scatterplot. Then what we're going to do is we're going to put a response variable there. Just like in science, the dependent variable goes here, the response variable goes here, and the explanatory variable goes along the bottom. Now, another way to remember, particularly the explanatory variable, where that goes, which axis is that? That's the x-axis, explanatory x-axis. Seems logical, doesn't it? So now all we have to do is decide which variable is which. So let's put it in a sentence. Does the age of a bike respond to its price, or does the price of a bike respond to its age? It's pretty clearly the second one, isn't it? The price responds to the age. The age doesn't respond to the price. If an expensive bike doesn't mean it's going to be an old bike necessarily, does it? So the price responds to the age. That makes price the response variable. And of course, the age becomes the explanatory variable. Okay, let's make the graph. So we're going price first. Let's see, our biggest price is $9,500. Our cheapest price is $2,000. So we could probably go up to about, I think there's 10 marks there. Yep, let's put them all on 10,000, up to 10,000. Across, we've got to go from half a year to 9.5. So let's go down to 10 across the bottom. There we go. And of course, now we get to go put in our dots. So 0.5 on the age is 9.5. So 0.5 there comes up to about there. Let's see. I'm not going to go through this with you. You know how to do it. You draw the dot, then you draw one at 8,000, then you draw another one at $9,000. So one there, and one up there. And eventually you'll end up with, I think there are 30 bits of data. And you have your scatter plot. That could take a while. So important things to take out of this. Put your variables in the sentence. Figure out which one's your response variable, which one's your explanatory variable. Label them. And draw your axes and draw plot your points. Let's have a look at the easier way to do it on your CAS. So same data. We're going to follow the steps on how to put it in. First thing we're going to do is we're going to need the data in a spreadsheet. So where's our spreadsheet button? There it is. So click on your spreadsheet button and it comes up, would you believe it, with a spreadsheet. Second thing we need to do, we need to enter our variable names. So they're going to go up in the cells up here. First one, our first variable, doesn't matter which way you put it in just yet. Good idea though, to put your explanatory first and your response afterwards. So I'm going to put age up in there. then we're going to shift across to here, and we're going to put the other variable, which is, of course, price. Please use useful names. Don't just use A and P, because if later on you're going to do another spreadsheet with A, then A is already taken and it'll bring up A automatically. So if you do age, I know it's a bit of a pain in the bum to go A, G, E, and then Z, P. It's not a QWERTY keyboard, R, I, C, E. Short-term pain, it'll pay off in the long run. All right. Third thing, you need to enter our data. So let's just do the age column first. I'm not going to go through all of this with you like this. We'll just do the first 4. So 0.5 is the first one. Enter, 1, enter, 1, enter, 1.2, enter. And normally you'd keep going and do the 1.9, 2, and so on, and it will go all the way down. Then bring your highlighted cell back up here and put the 9,500 in, followed by the 8,000, 9,000, 8,500. And when you've entered all your data, done. Make sure you press enter on the last one though, please. It'll give you an error and it'll say, oh, I think it's dimension mismatch. And it won't allow you to go any further unless you press enter on your 2,000 down here when you get it onto your spreadsheet. All right, now we need to insert a graph. Now, just like on a computer, how do we insert? Shortcut is Control-I. Control-I for insert. So press Control. Don't have to press them simultaneously. It's not a computer where you do have to. This you can just press Control and then followed by the I. And this comes up. We want to pick add data and statistics. That one. You never look, you can go by the icons. There's a calculator, there's a graph, but it's not the type of graph we're going to do. That's a XY plot. Geometry, no, list and spreadsheets. No, we've already done the spreadsheet. That looks like a graph we would want to do, doesn't it? So it's add data and statistics. So we'll click that and it comes up with, this is not all the dots, obviously, this screen. Some of you may have it in color. This one came up in black and white. All right, next thing we need to do is click on the x-axis, click to add variable, which is that one there. So we need to choose which variable to go there. Which one was it? The explanatory variable. That was the age, wasn't it? So you click on it and it'll come up with age and price. So you then select the explanatory variable, which is of course age, and press enter. And it'll line the dots up along the bottom. Doesn't quite look like a scatterplot yet, does it? So now we need to go to the y-axis, click to add variable. There it is. And the same thing will pop up, age and price. But this time, of course, we're going to select the response variable, which is price. And voila, it will create the scatterplot for you. Isn't quite what it looks like. I've taken a little bit of liberty, but it's pretty close. That it'll fit the whole scatterplot in to your screen. Cool, bit simpler, a lot simpler. Only what's hardest part was entering the data, really, wasn't it? Enter the variable names, enter your data, then insert and just click on the variables. Done, scatterplot, done. Awesome. What next? Well, we need to describe what's going on. A scatterplot's great, but we need to describe what's happening. So we've got our price in dollars. We've got our age in years. So some of the words we use are strength. So we need to talk about the strength of the correlation. Now this means, are the dots tightly packed? Are they moderately packed together, or they don't sort of look like they're together at all? Okay, now there's a bit of a graph I'm going to bring up just down here. It gives you a rough idea. Most textbooks have something similar to this. Okay, I'll give you a strong, a weak, strong, weak, moderate even, and no correlation whatsoever. You see how these ones, the dots are all just scattered randomly. If you look at strong, this is a negative, but we'll talk about that in a minute. See how they're very close to what's called a regression line, very close to a straight line. This one's very close to a straight line as well. It's strong because it's almost linear. These ones are weak because they're a bit separated, and weak and moderate is sort of between. We'll go with this negative one there. It's really strong. That's weak. And moderate is a little more packed than the weak. Do you see the idea between the three? So let's have a look at this one. What do we think this one is? So this data shows there is a, what do you think? I'd be probably going moderate, I think. There's a moderate association there, roundabout. There's a couple of outliers here, but we'll talk about linear regression in particular in a later video. Be careful, though, when you're talking about the strength, because it's very important when you're comparing that you look at the scale of the axes. Okay, if you're comparing two different scatter plots, the scales have to be identical, otherwise you can get confuzzled and muck something up. Second thing we need to talk about is the direction. Is it increasing or decreasing? Well, you could have picked that up from here. It says strong positive or strong negative. Do the dots generally increase or decrease? Positive or negative? So this one is pretty obviously going down, isn't it? So that would be a moderate decreasing or moderate negative. Either word is fine. And the third one we need to talk about is the form. Is it linear or non-linear? So that means, do the dots follow a relatively linear path, or there's a more obvious curve to them? Well, there's no real curve to that, is there? That's coming, if we put a line of best fit in there, a regression line, you can see they're all pretty much going down in that direction. When we say curve, it's something like it would go down and then up like this. Okay? There's no real curve to it. So we just say there's a moderate decreasing linear association between the age of a motorcycle and the price. Not overly accurate though, is it? No, it's all pretty subjective. So what I might think is moderate, you guys might think, well, that's actually closer to weak, I think. But again, you have to check the scale. There is a way though that we can get more accurate, and that's called using Pearsons correlation coefficient. This allows us to quantify the strength and direction. So it gives us a number that we can use to describe it, and we can be consistent with this number. All right, rather than just a guess, which is what we're doing by eye. So we've talked about the positive direction, the negative direction, and the strong, moderate, weak, and the no association, where it's all, the dots are all scattered all over the place. And we have the negative version of the same thing. So how we measure Pearsons correlation coefficient is between 1 and -1, 0 in the middle. 0 being no association. Makes sense, doesn't it? Okay, so the values, let's have a look at 0 first. So -0.25 to 0.25. So if you have an R value, now sometimes it'll be given to you, and I'll show you how to work it out from the calculator in a minute. If you have an R value which is between -0.25 and 0.25, you're going to have dots scattered all over the place. That would have a Pearsons correlation coefficient of, it would be weak. There'll be no association. If we start at the top, we have a bit of a range of values, 0.75 to 1. So that would be considered strong positive linear relationship. In here, 0.5 to 0.75, that would be considered a moderate positive. So that would be where the dots are around, but not too close, the straight line of best fit. If we had a look at a weak, that's between 0.25 and 0.5, and you can see the dots are a bit more scattered than the 0.7, or quite a bit more scattered, but you can still see there's some sort of direction to it, unlike the 0, where there is no direction. It's pretty much just filling out the whole box there, isn't it? Obviously, we're going to go down to -0.25 to 0.5. So all that means, instead of increasing now, it's decreasing. It's coming down. And then we go 0.5 to 0.75, negative, and that's moderate. and strong would be negative 0.75 to 1. Now, I haven't put the 1 or negative 1 graph on here. What do you think that would be? What's happening? It's going dots all over the place, dots a bit closer, and dots a lot closer. 1, 1.0 would be all the dots dead on the line. That would be a perfectly linear association. It's pretty rare you get that though. Anyway, just keep in mind there, it's 1 is right on the line. It's a dead straight line. Okay, that table's great, but you've got to work out Pearson's correlation coefficient first if you're not given it in the question. So how do we do that? Well, how's this for a formula? R equals 1 over n minus 1 times the sum of each individual x score minus its mean over the standard deviation of x times y minus each y value minus its mean over sy. Yeah, it's a fun one. Actually, it's not all that bad, but you do have to do a table and you have to work out these bits in particular step by step. And it just gives you more reason to say, don't forget your CAS. Do not forget your CAS. I would, if I were you, in your reference book, which you can take into the exams, have that written down just in case your CAS goes flat or whatever happens. But just don't forget your CAS and make sure it's charged. All right, here's our CAS again. So first thing we obviously need to do is enter our data. Done. This time I've entered all the data all the way down. If you want to go back and follow the steps along with this, I'll give you a couple of minutes humming music, or a couple of seconds humming music while you just skip back in the video and get that data into your CAS. Here we go. In 5, 4, 3, 2, 1. Oh, you're back. Welcome. Got all the data in the CAS? Fantastic. All right. Second thing we need to do is we need to press the menu button and up comes a menu. Surprise, surprise. We're going to be doing some statistic work. Now, this is set up actions, insert data if you want to change the data, if you want to change a table somehow, but no, we want the statistics from it. So we'll press statistics and what comes up, we're going to do some calculations on the statistics, aren't we? So makes sense. Let's press that one. And then comes up a bigger menu. So one variable was univariate, 2 variable. Now we are doing bivariate stats. You can get Pearson's correlation for that, but it gives you a whole heap of other things too that we're not really interested in terms of creating a scattergraph and a regression line. You will use it, but just not this time. Linear regression, now there's 2 of them, mx plus b and a plus bx. Now the operating system is using the American system. So instead of in Australia, we use y equals mx plus c. They use b for the gradient. That's all that is. So that's in your, if you're doing algebra mode, and this is what you'll see more often, a plus bx, when we're dealing with statistics. Now that one's pretty universal, actually, a plus bx. So we'll click 4 there, linear regression, a plus bx, and you will get a dialog box that comes up like this. Now, X list and Y list, they're the 2 things we need to fill in. We need to change our X and Y variables. So if you click on this arrow here, or click your right arrow on your keypad, this one here, what will come up is your 2 variables that you've got in your CAS. You've already put the age and price in. So we're going to click age because that was our explanatory variable, wasn't it? So click on age, then we come down to this one here and we click on price. Same thing, press the right arrow, comes up and click price. And it comes up with all these results. And it gives you your A value, which was your Y-intercept, your B value, which is your gradient, which makes sense, that's negative 650. Gives you R squared here. R squared, well, we'll talk about that in year 12. Year 11, it doesn't really go into this, but it is related to R. So what we need to do, R is the next one down. See how it's come down? So there's R, and it gives us our Pearsons correlation coefficient of negative 0.8970. So where does negative 0.897 fit in this? So negative 0.897 is actually going to be strong. So we'd write a sentence like, Pearsons correlation coefficient tells us that there is a strong negative linear association between the age and price of motorbikes. Remember how on the last one we looked at by eye and I suggested it looks like about a moderate? Well, it obviously wasn't. It was actually strong. Only way to get the actual value is by doing it on the CAS. If you are drawing a graph on this, there is another way. It involves R squared again. But again, we'll deal with that in another video where we're talking about linear regression. Okay, so bivariate data, where two variables you're checking if there is a relationship between the two. We're going to talk about the correlation between the two variables, how closely related they are. And you get to draw scatter plots on your CAS. Awesome. Time to go get some practice. Hopefully this has been useful. Feel free to come back and investigate some more. All right. Good luck. Have fun. Bye.